All right, let's just dive right in today. We are going to try and tackle one of the biggest questions, maybe the biggest question you can possibly ask. It's so huge the answer is almost impossible to imagine. Just how big is the universe?
Before we even get into the crazy numbers, I think the author Douglas Adams just hit the nail on the head. It's a feeling, right? As much as it is a fact. But today, we're going to try and put some real measurements on that mind-bogglingly big.
So, how do we even begin to wrap our heads around this? Well, we're going to go on a journey. We're going to start with something we can all understand, our home, our planet, and then we're just going to keep zooming out step by step into the cosmos. Okay, let's do this.
Our first stop is right here in our own solar system. And yeah, it feels absolutely massive to us, but as we're about to see, it's really just our own tiny little pond in a vast ocean.
So let's start with Earth, this little rock we call home. It's actually way bigger than you probably think. If you could hop in a car and just drive around the equator at highway speeds, no stopping for gas, no bathroom breaks, it would still take you over 17 days straight. Pretty quickly, we have to just ditch miles. They're about to become completely useless for where we're going. So let me introduce our first cosmic yardstick, the astronomical unit, or AU. That's the 93 million mile gap between us and our sun.
And how long would it take to travel that single AU? Well, if you got back in that same car for that 93 million mile road trip to the sun, you would need to pack for a 177-year journey.
Okay, what if you wanted to drive all the way to the edge of our planetary system, out to Neptune? Well, that little trip would take you about 5,000 years. That's longer than all of recorded human history.
And what this all points to is something pretty fundamental. Our solar system is, well, it's mostly nothing. It's defined by emptiness. The distances between the planets are so huge that if you actually looked at it to scale, the planets themselves would be practically invisible little specks.
All right, let's keep going, because now we're leaving the planets behind us and heading out to the stars. And for that, we need a unit of measurement that makes our 5,000-year road trip look like a quick walk to the mailbox. Say hello to the light year. Light is the fastest thing in the entire universe, period. Just to give you a sense of that speed, it takes a beam of light just 1.3 seconds to get from the Earth to the moon. A light year is the distance that same beam of light travels in one entire year, which is almost 6 trillion miles.
And even our closest stellar neighbor is a staggering 25 trillion miles away. Our fastest space probe, Voyager 1, which is screaming through space, it would take over 73,000 years to get there. It's just not going to happen. This analogy right here is probably the best way to feel the next jump in scale. Just imagine this. Our entire solar system, all the way out to Neptune, is shrunk down to the size of a US quarter. If that's the case, our home galaxy, the Milky Way, would be the size of North America. Now try to find that one specific quarter, somewhere on that entire continent. And putting these on a chart just makes it look almost ridiculous, right? Our whole solar system is so tiny it barely even registers. It's a rounding error next to our sprawling city of stars, the Milky Way, which stretches 100,000 light years from one side to the other. And how many stars are in that city? Well, the Milky Way is home to an estimated 400 billion stars, 400 billion suns, and we now believe that most of them have their own families of planets. So, we've journeyed across our solar system and across our entire galaxy. But now we have to take the final, absolutely mind-bending leap from our one galaxy to the vast cosmic web of countless others that fill the universe. That's right, 2 trillion. Based on what telescopes like Hubble and James Webb have shown us, astronomers think there are around 2 trillion other galaxies in the part of the universe that we can see. 2,000 billion of them. And that brings us to this incredible number. The observable universe, that's the bubble of space from which light has actually had time to reach us since the Big Bang, is 93 billion light years across. And you might be thinking, wait, if the universe is 13.8 billion years old, how is that possible? It's because space itself has been expanding the entire time that light was traveling to get to us. And here's where it gets even weirder. What is all that space actually made of? Well, everything we can see, Every star, every galaxy, you, me, this screen, all of it makes up less than 5% of the universe. The rest is made of mysterious dark matter and an even more mysterious dark energy that's actually making the expansion speed up. But this leads to the biggest question of all, doesn't it? Is that 93 billion light-year sphere, is that it? Is there like a wall at the edge? Well, all the evidence we have strongly suggests the answer is no. What we can see is just our horizon, not the end of the road. So this is the really crucial thing to get. Our observable universe isn't a box with walls. It's just a bubble defined by the speed of light. And beyond that bubble, the math suggests the entire universe is at least 250 times larger than the part we can see. And yeah, it could very well be infinite. How can something be finite but have no edge, or actually be infinite? Well, it all comes down to the overall geometry, the actual shape of space-time itself. There are really three main possibilities on the table. It could be closed, like the surface of a sphere. You travel in one direction long enough, you end up right back where you started. Or it could be open, kind of shaped like a saddle. But our best measurements, they all suggest it's almost perfectly flat, with just a tiny margin of error. And a flat universe, just like a flat piece of paper on a table, would extend forever. After a journey across trillions of miles and billions of galaxies, it is so easy to feel impossibly small. But let's bring all this back home for a minute and think about what this incredible scale really means for us. This is such an incredible thought. We're not just living in the universe, we are the universe. Every single atom in your body, the calcium in your bones, the iron in your blood, all of it was forged in the heart of a star that exploded billions of years ago. We are literally made of star stuff. And maybe this is the most profound idea of all. In this vast, seemingly endless cosmos, on this one small blue dot, a part of the universe became conscious. We are a way for the cosmos to look back and wonder at its own incredible, mind-boggling scale. And that's a pretty amazing thought to carry with you the next time you look up at the night sky.